students. So today we will see on the Python program for eigenvalues and eigenvectors. So if a square matrix A is given to you, square matrix, it might be a 2 cross 2 matrix or 3 cross 3 or 4 cross 4 such matrices, then how do we find the eigenvalue of that particular matrix? So this we know how to do it manually. Okay, so we will find the characteristic equation by taking determinant of A minus lambda I. We will find the roots of that characteristic equation that will give the eigenvalues. With respect to those eigenvalues, we will find the eigenvectors corresponding to the eigenvalues which we have got by either Kramer's rule, either by solving those equations, we will be finding the eigenvectors. So here, using Python, how to solve or how to find out the eigenvalues and eigenvectors of a particular square matrix, that we will see today. We will be using many packages for solving mathematical problems in Python. So before we used to do in Python online compiler without using packages, or otherwise we had used SymPy. SymPy is also a package wherein we solved the multivariate calculus, that is the differential equations we had solved using SymPy package, and also to use that code which is for mathematical logics. So for that also we had used a SymPy package. But here we use another package under SymPy. See, logical expressions in SymPy. If you see here, it's given logical expressions in SymPy. So that is numpy. Numpy means numerical package it is. It's a numerical Python. So numpy is a Python library used for working with arrays. Arrays means with respect to matrices. So wherein in matrices each column or each row, how it is represented. So that we will give in arrays in Python code. So it also has functions for working in domain of linear algebra, Fourier transforms and matrices. So we will be using this package. This was created in 2005 by Travis Oliphant. So it is an open source project, you can use it freely. So this numpy means it stands for numerical Python. Okay, so this package we will use and find the eigenvalues and eigenvectors for a particular matrix. NumPy has the numpy.linealg.eig open close bracket. See here in our previous, that is in our mathematical logic, we saw that we had used Boole algebra, that is Boolean algebra, wherein we used only the numbers such as 0 and 1. That is of Boolean algebra. That means only true or false we had used. So we say it as Boolean algebra. But here NumPy has the code which is numpy.linealg, that means linear algebra. So in NumPy we say, in Python we say it as linealg, that is linear algebra dot eig. Eig means eigenvalue and eigenvectors together. So eig, we say eig of open close bracket, wherein we will give one matrix inside that bracket. So this function gives us the eigenvalues and eigenvectors of the square matrix. Okay, so with respect to this line, that is this line numpy.linealg.eig open close, we will use 3 to 5 lines of code to find out the eigenvalues and eigenvectors of a matrix. Now I will explain you with respect to a 2 cross 2 matrix. So here import numpy as np. Okay, so we are importing numpy which is a numerical Python as np. So first line will be import numpy as np. Remember, for matrix we are using numpy. So that will be the first line, it is fixed. Now second line says a is equal to np.array. Now open the bracket, again open a square bracket, then give 3, 1, that this 3, 1, this will be the first row of the matrix. Okay, so this will 3 comma 1, that will be the first row of the matrix, comma, again in the square bracket, give 2 comma 2, that will be the second row of a square matrix. So matrix, how it will be represented in square brackets, the first row and the second row, isn't it? So here we give A is equal to np dot array, open a simple bracket, then again within that simple bracket open a square bracket. That is how we are representing a matrix in square bracket. So open that square bracket. Now first row, give it again in square bracket with 3 comma 1. This is the first row, comma. When you are entering the second row, again with the square bracket you enter 2 comma 2. This is the second row. So close that particular brackets. Be careful about the brackets. So first you are opening a simple bracket, then you are opening a square bracket to represent the entire matrix, then you are opening another square bracket to represent the first row, close that square bracket, then again comma, open the square bracket to represent the second row, close that square bracket. Now w comma v, this is of your choice, whatever you want you can give here. Instead of w comma v, you can give any other alphabets also. You can give C, D or anything. So w comma v is equal to what? We want linear algebra, that is np, that is this numerical Python np dot linear algebra dot eig means eigenvalues and eigenvectors together in Python. So eig of what we want, of this matrix A, that is A means all this, np dot array of this. This will give the second line will give the matrix. Now eig of A means eig of that particular matrix. Close the bracket. Now print w, print v. Okay. Or either you can give here print in inverted commas, you can give the eigenvalue, comma, then w. Again in the next line, print in inverted quotes, you can give the eigenvector, comma, v. Like that also you can give. So that you get the eigenvalues. Corresponding to those eigenvalues, you will get the eigenvectors. Okay. So here if you see, w gives the eigenvalues. So here the eigenvalues are 4 and 1. Print v, v gives the eigenvectors. So for 4, the first the row, that is the eigenvector. For v, that is for 1, the second row, this row is the eigenvector. Okay. So this is how we will be using the code and we will be executing the program. You can follow the same code, but here if you have a 3 cross 3 matrix, in the first row, that is here, you will have comma another number. Here also in the second row you will have comma the other number. Then again you will have the third row. So there you have to put a comma and open a square bracket and give the last row. So that's all. So same command follows for rest of the matrix. So I will tell you here. Yes, see here. So this is an example for a 3 cross 3 matrix. But here if you see, instead of using this np.linalg.eig of A, that they have imported as in the second line from numpy.linearalg import eig. So this is an extra line. So I don't want you to follow this command. If you are okay with this, you can follow this command also. Or otherwise, I'll give you a simple code with respect to this. So I want everyone to use this command. This command is very simple compared to this, because here 2 lines you have to remember. So instead of that, we will do everything in the same command. So this command, we will type it and we will execute. So here instead of using this third line np.linalg.eig, this they have imported in the second line. And in the third line easily they have given eig of A, because already they have imported this in the second line, so third line was easy. That's what is done here. See, eig of A. because I have used from numpy.linalg import eig. This here itself I have used. So this line is just eig of a. So any command which you feel comfortable, you can follow that. Okay, done. So here if you see, it's a 3 cross 3 matrix, first row, comma second row, comma third row. So this is how the program works on. So here again, if you see here, this is the matrix, first row, second row. So that's what is done here. So I will execute one program for you and execute for this matrix, for this okay, both I will execute. I will execute for this 2 cross 2 matrix, also I will execute for the 3 cross 3 matrix, and I will show you how the program runs. Okay, yes. So now we will go to Google Colab. Okay, now we are in Google Colab. Text. So let me type that we are finding the eigenvalues and eigenvectors for 2 cross 2 matrix. Okay, this is the text which I have given here. Now the code, let me type the code here. So the first code is import, first line is import numpy space as np, numerical Python. Okay, then enter. The next line is a is equal to np. So I am doing it for this third example. Okay, doing it for the third example. A is equal to np. The first row in the third example was -1 and 3. Okay, so a is equal to np dot array. Array means we are representing a matrix in an array, that is in one line we are representing, so we will be mentioning it as array. Open the bracket, again open a square bracket, that is we are representing a matrix inside this array. So array will be in open brackets, inside that we are representing the matrix, so that will be in a square bracket. Again open a square bracket to represent the first row. So what was the first row element? -1 and 3. So -1 comma 3. So this is done with the first row. Outside of the first square bracket, give comma, again open a square bracket to enter the second row. It is -2 comma 4. So the brackets are closed here. So the brackets are closed. So once the brackets are closed, come out of the brackets, give enter. Now what we have to give? W comma v, that is equal to np dot, we have imported numerical Python, we have given the input for matrix. So now we want the eigenvalue of that matrix. So w comma v should be equal to numerical Python dot linalg. So linear algebra, linalg, linalg dot eig of a. So here it keeps giving you some hints when you're typing. So don't worry about that, you just type your command. So print, open the bracket. So here I told you in double inverted, so you can give the command as you wish. So I'll give it as eigenvalues of a is AR. Outside the inverted, put a comma and execute W. We want to print W. Okay, then again print, open the bracket, in inverted commas give eigenvectors of AR. A means it's a matrix here. You can either give capital A, so whatever the variable you are defining it in the left hand side, the same thing you have to give it in the print command, otherwise that variable will not be defined. Okay, print v, that's it. So now we have imported numpy as np, a is equal to np dot array, the first row, the second row within the square brackets, and the matrix, that is matrix also in square brackets. Outside there will be a open bracket. Then w comma v represents np dot linalg dot eig of a. Eig of a gives you eigenvalues and eigenvectors in linear algebra. So we are printing eigenvalues of a as w, eigenvectors of a are v. Okay, let us run the code and check. So here if you see, you have got the eigenvalues of a as 1 and 2, and the eigenvectors are, so this, the first row, this row represents, see actually this also the answer has come in an array. So this square bracket is a matrix. Inside that square bracket there is another square bracket that represents the first row, that is the eigenvectors corresponding to the eigenvalue 1. The second row within the square bracket, that represents the eigenvectors of the eigenvalue 2. So first row represents the eigenvectors of the eigenvalue 1, second row represents the eigenvectors of the eigenvalue 2. So this is how we have to do the code and execution. Same way do it for 3 cross 3 matrix. Okay, for a 3 cross 3 matrix. So let me type it as, so this is done. So text, so now I'll give the eigenvalues and eigenvectors of 3 cross 3 matrix. Okay, now code, same code you have to type, but with 3 cross 3 matrix, same thing with 3 cross 3 matrix. Import numpy as np, enter. Now let me give capital A. Capital A is equal to np dot array, open the bracket, again open the matrix bracket. Now give again, open the first row again in square bracket. First row is 6 comma minus 2 comma 2, so that is done. Come out of that first square bracket, comma, second row with again a square bracket, minus 2 comma 3 comma minus 1, close the square bracket, comma, again open a bracket for the third row, 2 comma minus 1 comma 3, close the square bracket, again close the matrix bracket, close the array bracket, enter. Now we will give it as capital W comma capital V, whatever you wish you can give. You can give small w, small v also. So that will be again np dot, we want linear algebra dot, what we want, eig of a. So in linear algebra we are studying eigenvalues of a, so in that way also you can remember. And we want numerical Python for the matrix. So in that way, np dot linear algebra dot eig of a, capital A, close the bracket, enter. Now you give print. So here it will keep suggesting you some value, something, whichever you want. So since it's an online, so it is suggesting you what is whether you want to print option, print function. So if you know the command, just keep printing. Print in inverted, it's your wish. I told you. You can give eigenvalues are. That's also enough. Outside the inverted, give comma. Outside the inverted, you have to give comma and you have to type capital W, because I have given here capital W. So I am giving here also capital W. Remember, outside the inverted comma, you have to give a comma, then you have to type W. This W should be in black. Okay, it should not be inside the inverted. If you give inside the inverted commas, that means it's of your wish. It will not be affected anything to your output. It will come inside eigenvalues are W. Only so much it will come. What's the answer you want to execute? That will not come. So in order to execute that answer, you have to give comma W. Now the last line is print eigenvectors are comma V. That's it. It's done. So you can execute it. So if you see here, the eigenvalues of this is 8, 2, 2. So 8, 2, 2 eigenvalues are repeated here. The first eigenvalue is 8, the second eigenvalue is 2, the third eigenvalue is also 2. Eigenvalues are repeated here. Okay. So the first eigenvector corresponding to the eigenvalue 8 is this first row of this square bracket. Second row represents the eigenvectors with respect to 2. Third row represents again the eigenvectors with respect to the second eigenvalue. So when the eigenvalues are repeated, your eigenvectors will be in terms of k. If the eigenvalues are repeated, we will consider one value to be k and the other value we will find and then replace k with some value so that we get the eigenvectors. So that way only this is done. So we have got the values for eigenvectors, eigenvalues of 8 as the first row. For eigenvalue 2, we got the eigenvectors in the second row. For eigenvalue 2 again, which is repeated, we got the third eigenvector. So this is the way of doing commands for eigenvalues and eigenvectors of a matrix. So just 5 lines of command, so it's easy to practice, and the rest of the problems can be solved just by replacing this array. This matrix only has to be changed, otherwise everything will remain the same. Okay, so done.